Hello, class. So we are now in section 2.4, which is this is the first section that will be part of test 2. All right. And it is called average rate of change. So depending on who you ask, this might actually be the most important section in all of pre-calculus because this is like almost calculus. Okay. For us, it's not that important. It is important, but I'm not gonna go as far as calling it the single most important section. Okay. So average rate of change. Okay, so first of all, if you ever see a triangle um in math, that means change. All right. I don't know why math people just did that. Well, actually, it's probably the capital letter delta, but whatever. So average rate of change is the change in y divided by the change in x. Okay, which will be the formula f of b, which that's like y, 2, minus f of a, this is like y1, over b minus a, which this is like x2, this is like x1. Okay, so if you plug in the x2s, y2s, y1, x1s, I want you to notice something, all right, because we're going to find the average rate of change of this function, which is a line, so like 2x plus 4, okay? Between, let's just say x equals 1 and x equals 3, okay? So you always need to be told when you're doing average rate of change, you need to be told between where and where, right? Because that's where your average is going to be happening, okay? So between x equals 1 and 3. So let's plug in the formula. So average rate of change equals, so f of b, so I'm going to call this one b and this one a. So f of 3 minus f of 1 over 3 minus 1. So then I'm going to plug in. All right, you could have done this instantly if you wanted to also. Minus, I'm going to put parentheses. Plus 4, okay. All over 3 minus 1 is 2. Continue on. So 6 plus 4 minus 2 plus, well, minus 4. 2 minus 4. Those can cancel. And you're going to get 4 divided by 2, and you're going to get 2. Okay? And one thing I want you to notice, 2, and the slope, right, because this is a line, right, and the slope is 2. So actually, if I did the same function, but I did between x equals like 2 and x equals like 5, for instance, if I do the whole thing all over again, okay, so average rate of change. So if I plug in 5, I'm gonna get 14 minus, and if I plug in 2, I'm gonna get 2 times 2, 4 plus 4, 8, all over 5 minus 2. That's gonna get me what is that gonna get? 3. That should get me 6. 6 over 3 is 2. And look, it's the same, okay? So this is a fact I want to tell you. The average rate of change for a line, okay, if you plug these in, the average rate of change for a line is just the slope, okay? So it'll always be 2. It actually doesn't matter where you are. The average rate of change of a line will always be the slope, okay? Now, let's move on to more interesting examples, okay? So if I have a function, so x minus 2 squared, okay? Obviously I could FOIL this if I really wanted to. I would advise probably not foiling it though. But as you can see, like, where's the slope? There is no slope, right? At least not the way we know it. So here we actually have to use the formula. So I'm going to do this between x equals 1 and 3. Again. Okay. So average rate of change equals, and I'm going to plug in my 3. So 3 minus 2 squared minus 1 minus 2 squared all over 3 minus 1. So this is going to be 1 minus 1 over 2, which is actually 0. So you get 0 as your average rate of change. Okay? And that's interesting because that means you're not really changing, right? But if we draw what's actually happening, okay, is we're finding the slope of a line, okay? So here at 2, okay, so we're going to go to 3 and 1. This is 1. So if we look, right, we have the point 1, 1 and the point 3, 1. If we connect them, that is a flat line. That's a horizontal line, and this line does have slope equal to 0. So this line is called the secant line. Okay, and this is the line whose slope tells us the average rate of change between the points. Okay, and so here now, if I actually change where I'm doing this, so let's go between x equals 2 and x equals 3. So if I plug this in, average rate of change equals, so now I'm going to plug in 3 again, so I'm going to get 1, but this time 3 minus 2, and then I'm going to plug in 2. 2 minus 2 is 0, so I'm going to get 1 over 1, which is 1. So you see the average rate of change between 2 and 3, this line's slope, which I should have done this in a different color, this secant line's slope is 1, which is why the average rate of change there is 1. Okay? And now you can get a little bit philosophical, I guess. Normally, if we actually care about the info we're getting, we would want to find the average between closer numbers, right? Because saying the average rate of change is 0 right there is kind of a lie, right? Like it's technically true, but like a lot's happening here. So we'd want to know more info. So we'd want our like time to be smaller to be more accurate. Okay. All right. So now I'm going to go over some facts. Okay. These may or may not be obvious to you. They were not to me until I wrote these down. Okay, so the first fact is if a function is increasing, so let's remember increasing, decreasing, constant, okay? If it's increasing from A to B, then the average rate of change is positive. Okay, and that makes sense, right? If you're increasing, then you're changing in the positive direction, right? And then here's an example, right? This function increases after 2, right? And we saw that after 2, I got 1 as an average rate of change, which is positive. Okay. Now, 2, if a function, okay, is decreasing from A to B, then the average rate of change is negative. All right. which I hope makes sense, right? That means we're going down, so the secant line would be down. And then third, which this is the first one I actually told you, for a linear function, f of x equals mx plus b. Okay, average rate of change equals m, which is the slope. Okay. So now that we know average rate of change, this actually opens up a whole new world of word problems, which I know is horrible. Okay. But basically this lets us calculate like average speed. Okay. So let's do a word problem. Okay, so if an object is thrown off of the side of a building, is dropped from a cliff. Okay, so we're dropping an object from a cliff. Then the distance it falls after t seconds, okay, is given by the function fd of t equals 16t squared. Okay. Find average rate of change. And then there's two parts. Okay, so part A. So you want to find the average rate of change between t equals 1 and t equals 5. Okay, so let's just plug in. So here's our function. Okay, so we're going to plug it into the average rate of change formula. So calculator probably required for this. 16(1). 5 minus 1 is 4. So 4, so 16 times 25 minus 16. Which let me try and do something fancy. So that's 16 times 24 divided by 4, which that is going to be 4 times 24, which I still don't know off the top of my head, unfortunately. So let me smash that into a calculator. And we see that we're going to get 96. Okay. So the average rate of change is 96. And the word problem actually doesn't give me a unit. So just 96, I don't know. Units. All right. Bad word problem. It should be like kilometers per second or something. Well, it's units per second, that I can tell you, because they gave us t in seconds. But they didn't tell me like miles or kilometers or meters or anything. Okay. But here we go. All right, it's not that hard. You literally just plug into the formula. Okay, this is one of the easiest kind of word problems, I think. Because there's not really a lot of thinking. It's just like identify and plug in. Okay. But now for part B, they want you to find the average rate of change between t equals a and t equals a plus h. Okay, which this is a little weird, but it's actually very important. Okay, so actually, yeah, just I don't know why I wrote that down. Average rate of change. Okay, so we're gonna plug in the stuff. Okay. So d of a plus h minus d of a over a plus h minus a. So if we simplify this down, this should look very familiar, okay? Especially if d was a function like f, okay? This, that's the difference quotient. So hopefully you have like your notes or whatever pulled out and you can like look back a couple of pages and be like, oh yes, that is the difference quotient, okay? So average rate of change is actually very much related to the difference quotient, okay? So this essentially is me asking you to find the difference quotient, okay? But let's do it. Okay, so 16a plus h squared minus 16a squared all over h. So here I'm gonna have to FOIL, so a squared plus 32ah plus 16h squared minus 16a squared. Those cancel, and we're going to get 32a. I'm gonna factor out the h automatically. I hope that's okay. H, cancel, cancel, and we get the answer. 32a plus 16h. Okay. And yeah, that looks like the difference quotient, right? The h cancel at the end and we get this thing. But it's also the average rate of change between these two things. And if you notice, you could think of t, right, as time, right? So if a was like 1 second, this is between 1 second a and 1 plus h. So this is like how much time, right? How much time I'm adding. So you might be wondering, what if h goes to 0? If h is 0, then I'm finding the quote-unquote average rate of change between 1 and 1, right? Which is actually not the average rate of change anymore. That's the instant rate of change, all right? Which is actually called a derivative, which is actually like half of calculus. Okay, so that's why some people say this is the most important section in pre-calculus, because this is actually basically calculus as soon as you plug in h equals 0 here. Okay, but we are not going to care that much, right? This is philosophically extremely important, but for us, we're just simplifying some fractions. Okay. All right, but that's it for section 2.4. All right, it's just this formula, honestly. So you should memorize this. Average rate of change, all right, is equal to f of b minus f of a over b minus a. All right, that's really the key part of this section. But hope you guys are good. All right, and see you next class.